Hello, welcome to part 2 of step 32. So this section is all about probability of geometry concepts. This is really the only one that I feel like sort of relates to what we've been talking about all year. And we kind of paired it with permutations and combinations because it just kind of worked out that way and how to divide up the chapters. So we're going to start by talking about probability with just segment lengths. So let's say we had this segment here, AD, and we wanted to find the probability that, all right, we're going to put another point, maybe a fifth point somewhere on this segment. What's the probability that it would actually land between points B and C? So this equation's a little confusing. So really on the bottom, just like we want total number of outcomes, for this we would want the total length of the segment. And then on top, we would want, spell total right, like the desired portion, let's call it. Okay, so if we were asking like, what's the probability that we plot this extra point on AD, what's the probability it actually lands between BC? We would put BC as our desired length, and then AD would be the total length. And we would be given measurements to obviously figure that out. So if we look at our first example, we want point X is chosen at random, so we're putting some X on JM. We want the probability that X is actually on KL. So we want the probability X is on specifically the piece KL. Okay, so our total segment from the beginning all the way to the end would be J to M. But we specifically are only worried about traveling from K to L. So K to L right there is just, is just 7. And then J all the way to M, so we would do 3 plus 7 would be 10 plus 4 would be 14. Okay, so just to practice, if we wanted to simplify this fraction, hopefully you can see these are both multiples of 7. This is exactly 1/2. And then if we wanted to put 1/2 as a percent, we could say 50%. Okay, if we do a more complicated fraction, I'll show you how you can do that in your calculator. Okay, so I think that's pretty straightforward. So for now, I would take 7/14, 1/2, or 50%, whichever one you'd like to do. All right, so now we're going to talk about probability in terms of sort of a timeline and some sort of interval of time. So we have, you arrive at Addison on the red line at a random time. What is the probability you will have to wait 3 or more minutes for a train? So I forgot to put this in here. But the Chicago Transit Authority train arrives or departs a station every 15 minutes. So the train arrives or departs every 15 minutes. Okay, so if we were going to make that sort of like a timeline like you might do in history class, every time 15 minutes hits, a train shows up and a train leaves. So our timeline is going to start at 0. This line is not straight and it's really bothering me. And it's going to end at 15 minutes. So let's put some, let's say like, I don't know, this is 5, 10. We don't have to label everything. Just give us some sort of interval so that we know. Okay, we want the probability that we are going to have to wait 3 or more minutes for this train. So let's just say we walk up at a random time. We're not sure when the last train showed up, but we want to see, are we going to have to wait longer than 3 minutes, or will it show up pretty quickly? So if we did this, 3 minutes on our timeline would probably be like about here. Oh, geez. It'd be like about here. Okay, so if we started at 3 minutes and we wanted 3 or more, we're really looking at our timeline from 3 to 15, right? 3 or more would be, are we going to have to wait 3 minutes? Or are we going to have to wait 15 minutes or somewhere sort of in between there? So it's kind of resembling example 1 in the fact that we have this segment that's maybe, I don't know, 15 inches long, and we want whatever segment we're looking at to be 3 or more inches long. So same sort of idea as the first one. We want sort of our desired time over the total time of the interval. Okay, so if we count from 3 to 15, that's a difference of 12. And then the total time of the interval that the train's actually going to show up is 15. So the probability that we're going to have to wait 3 minutes or longer is going to be 12 over 15. Okay, so if we wanted to simplify this in our calculator, the calculator will nicely do it for us. Okay, we can type in, clear that. So we could do 12 divided by 15, just like our fraction says, and hit enter. Okay, if we wanted this as a simplified fraction, we could hit the math button, which is right under alpha, where we went yesterday or in the previous video for permutations and combinations. And then we're going to hit enter twice. So that was math and then enter twice. So this is really the simplified fraction of 4/5. If we wanted to convert this to a percent, we could again type in 12 divided by 15. We get 0.8 again, and we could multiply this by 100. Multiplying it by 100 moves the decimal 2 to the right, and this is really equivalent to 80%. Okay, so all of these acceptable answers, simplified fraction would be 4/5, percent would be 80%. All right, we're going to move into the last two concepts are, the next one is probably the most relative to geometry. It's talking about actual area. So we've been doing these a little bit here and there, but if we want, let's say, like for this example, we would say, okay, we know that maybe we're going to throw a dart or drop our pencil somewhere within this blue region. What's the chance that it actually ends up on the red circle? Okay, so just to clarify some areas that you may need to know that you may have forgotten. Let's see, area of a rectangle is length times width, or if you want to say base times height, that's fine. We also have area of a triangle might pop up. And that is 1/2 the base times the height. Or you could write this as base times height over 2. And the one we're going to use for this next example is area of a circle, which is pi times the radius squared. Okay, those are probably the 3 biggest ones. So in this next example, we have a skydiver, and he is falling to the ground, and he wants to land on this target. Okay, we know that he's going to land on the target, but we specifically want him to land in the red circle. Okay, so let's draw this picture for ourselves so we can kind of get a better idea of what the picture looks like. So on the inside, we have a little red circle. And then we have this like cream colored circle. I'll just put that in black. It's just going to be harder to label for us if we don't sort of make a little sketch. And then we have the blue one. Okay, obviously this is not going to be perfect, but just to kind of give you some sort of idea, so we can label. All right, so it says we have concentric circles, which means that they all have the same center but a different radius. We want if the diameter of the center circle is 2 yards. So let's think. The center circle, the red, put this in red. The red has a diameter of 2 yards, which means its radius is 1 yard, because we're worried about radius because we're talking about what's it called? Area, which is pi times the radius squared. And then it says, and the circles are spaced 1 yard apart. Okay, so that means between these two, there's another yard, which means, I don't know, we can call it, I'll just call it the yellow circle. That means the yellow circle has a radius of 2 yards. And the blue one, we go another yard. So the blue one has a radius of 3 yards. Okay, but we want the probability that he's going to land in the red. Okay, so we want the desired area over the total area. Okay, and remember, area of a circle is pi r squared. So if we're thinking about total area, that would be the blue circle. So we would have pi times the radius, which we already figured out was 3, and we're going to square that. And then what else do we have? We want red, so we want radius of 1, so pi times 1 squared. Okay, before you put this in your calculator, we can actually simplify this by hand. 1 squared, hopefully you know, is just 1. So it's really just pi times 1. And then we have pi times 3 squared, and 3 squared is 9. So really we have pi times 1 on the top, pi times 9 on the bottom. Well, conveniently, since pi is on the top and the bottom, these are actually going to cancel. So this will cancel here, that'll cancel there. I guess I should have picked a different color so you could see it. Cancel, cancel. So really, the probability that we land in the red one, knowing that we're going to hit the target, is 1 over 9. Okay, so if we want to put this as a percent, we can't simplify it anymore because 1 and 9, there's no factors. So we can type in 1 divided by 9, enter, and then we can hit times 100. So really, it's about 11.1%. Okay. So the last thing we're going to talk about is finding probability when talking about a circle. So this kind of ties back a little bit. We started kind of talking about spinners in the last step, but then we also, in our last unit, talked about circles. So think about in a circle, if we go all the way around a circle, just like if you spun around in a circle, you would go 360 degrees. So if we wanted, we're still going to talk about, you know, desired area or desired section over the total. If we know, like in this first one, we want to land on yellow, the probability we would land on yellow is 45 degrees of the circle, and the whole circle, all of those pieces should add up to 360. So the chance of landing on yellow would be 45 over 360. Okay, and we could put that as a percent. 45 divided by 360, and then multiply it by 100. So 12.5%. Okay, same sort of idea for B, pointer landing on purple. So purple is 105 degrees over 360. 105 divided by 360 times 100. 29, about 29.2. Okay, we'll do one more. Oops. So for C, we want pointer landing on neither red nor blue. So we don't want it to land on red or blue. So we basically want yellow, green, and red. So you can think about it one of two ways. We could add the red and the, I think I said that wrong. We don't want red or blue, so we want purple, yellow, and green, basically. So we could add together the blue and the red, subtract it from 180. Or we could just add everything else that's not blue and red. So we could do 105, 45, and 90. I'm going to type that in my calculator. It is 240. So really, we're just worried about 240 degrees out of the 360, which I should know what that is off the top of my head, but we're just going to check. Is it's 2/3, so it's 66.7%. And that is it for step 32.